let's have examples, numerical examples on calculation of resultant of forces or vectors. And the first example that we have here is that we're having two forces, 4 newtons and 6 newtons acting on a body. Calculate the resultant force, calculate the resultant vector. So we say that a resultant vector or a resultant force is one force, it is a single force, or it is a single vector, which is going to be having the same effect as very many other forces or vectors acting on the same body. So we're having two forces, 4 newtons and 6 newtons acting on the body, and we're supposed to calculate for the resultant of those two forces there. One thing that we're going to note here is that when calculating for the resultant of vectors, direction is paramount. Direction is very important. So if the forces are pointing in one direction, we simply add. So it is the same as having 4 newtons plus 6 newtons, getting the answer as 10 newtons to the right. That is our answer to this question here. The original vectors or the original forces are called components. For example, 4 and 6 are called components, and the final one is called the resultant. The resultant of vectors or the resultant of forces, for example. Number 2, we're having two forces still acting on a body, but this time around the forces are pointing in opposite directions. So for this case, what do? What we do is that we identify which force is bigger or which force is stronger than the other. So the smaller force is subtracted from the bigger force. In other words, it is the same as having 6 positive. You know that when we go on this other side, we have the positive, and when we go on this other side, we have the negative. For example, on the number line. So it is the same as having 6 newtons minus 4 newtons, and the answer will be 2 newtons to the right. So this is the same as 6 minus 4, giving us 2 newtons to the right. Likewise, if it was like this, a body, and then you have 10 newtons pointing to the left, then we have 6 newtons to the right, the resultant force would simply be equal to 10 newtons. You get the bigger one minus the smaller one, giving us 4 newtons to the left. So that is how we calculate for the resultant of vectors or the resultant of forces when given forces acting on a body. So in short, we're saying that if you have a number of forces acting on a body, and those forces can be replaced by a single force, that single force will be having the same effect as 2 or more forces acting on that same body, and that is what we call the resultant of forces. Now pause the video and try out this example. Calculate the resultant of those two forces. Okay, very good. I hope that you got that answer there, that since these two forces are pointing in the same direction, we simply add that 2 plus 3 will give us 5 newtons to the right. That is good, that is great. Other examples, pause the video and try out all of these. Number 1, number 2, number 3, number 4, and number 5. Okay, that is good, you've tried out. So number 1, we're doing correction is, number 1, the two forces are pointing in the same direction. 4 plus 6 we get 10, so the answer is 10 newtons. Number 2, 3 newtons and 4 newtons are pointing in opposite directions. So what do we do here? You get the smaller one subtracted from the bigger one. So for this case, we'll be having 4 minus 3, giving us 1 newton. Which direction will be this 1 newton? It will be to the right. So our answer is 1 newton to the right. Number 3, two forces pointing in opposite directions. 7 is stronger than the 3, so we shall simply get 7 minus 3, giving us 4 newtons. Going where? Downwards. That is great. And then last but not least, number 4, forces are pointing in opposite directions. Still 6 is bigger than 2, so we subtract 2 from the 6 and we get our answer as 4 newtons. And lastly, number 5, These ones are having forces pointing in opposite directions, but these forces are equal in magnitude. So when you get 4 minus 4, you get your answer as 0. In other words, these ones are balanced. Sum of forces in one direction is equal to sum of forces in the opposite direction. So 4 and 4, we shall get the resultant as 0 force, 0 newtons. So how about this? Number 6, try out this very first. We have a body. This is 10 newtons, this is 6 newtons, this is 4 newtons, and this is 8 newtons. Try out this number 6 very fast. Okay, I hope that you've got it right. So let's do corrections and we see. Now we see that 10, 6, and 4 are all pointing to the right. So we shall simply have 4 plus 10 plus 6 giving us 20 newtons. So if you try to redraw this, this will be the same as to the right we have 20 newtons, to the left we have 80 newtons. And therefore our resultant will be 20 minus 8, which gives us 12 newtons to the right. That is very good. So in case you want, you can redraw and come up with this diagram here. Or in case you don't want, then you can still leave it out and simply say that we have 4 plus 10 plus 6 then minus 8 and get the answer straight away. That is very nice. So in other words, all these examples are for forces acting in one plane, on one line, for example, either vertically or horizontally. So if you're having two forces or more forces acting in the two planes, by the planes I mean either vertical or horizontal. So what do we do in this case? For example, in example number 1, the questions are the same and the question is saying that calculate the resultant of forces acting on the objects below. So in this case, what we do, we're going to use an idea from mathematics using one of the theorems concerning the right-angled triangle. Do you remember what that is? Yes, the Pythagoras theorem. So on the triangle, the longest side is C. It must be a right-angled triangle. The longest side is C, and either this one can be A or it can be B. Even this one can either be a B or an A. In other words, you can interchange the A and the B. And how does the Pythagoras theorem state? Yes, it is A squared plus B squared equals to C squared. Very good. So, having that in mind, when you're dealing with getting the resultant of forces for such kinds, for example, in number 1, what we do is that we're going to draw up a right-angled triangle. And how do you do that? You simply pick on any force that you want to draw. For example, you can draw this. You can begin with the 3 and indicate that this 3 is going up. That is 3 newtons. And where it stops, that is where you start from to draw the next force. This one is going in this direction, and this is the 4 newtons. And then our resultant will be from the start of the 3 to the end of the 4 using a double arrow. That is where you have the resultant of forces acting for that case. So I've begun with a 3, you can as well begin with a 4. In other words, you can simply draw it like this, that we have 4 newtons, then the 3 beginning from here, it is going up, indicate this is 3 newtons, and then the resultant is from the beginning of 4 up to the end of 3, and that is the resultant. So you can see that it is going in the same direction as this. Now, since this one is a right-angled triangle, what we do is that we use the Pythagoras theorem and say that A squared plus B squared is equal to C squared. So the A can be a 3 or it can be a 4, and the B can be a 3 or a 4, depending on what you want. So 3 squared plus 4 squared is equal to C squared. 3 squared you get 9, 4 squared you get 16, this is C squared. 9 plus 16 you get 25, this is equal to C squared. So C squared is equal to 25. From this step, what we do? We take the square root. So the square root of C squared is C, and the square root of 25 is a 5 newtons. And please use a calculator. Therefore, our resultant force is equal to 5 newtons. And that is what we do, as simple as this. Now, you may wonder that will the body actually take that route? I just need you to try out this one practically. Get 2 pieces of threads, tie them on an object, maybe your pen, a calculator set, and make sure that the 2 threads are pointing like this 3, where the 3 is pointing and where the 4 is pointing. And then use both of your hands. The 3 is up and then the 4 is the other side. So pull from this way and from this way at the same time. So you'll find out that the body will actually not go neither upwards nor to the right, but instead the body will be going in this direction. That is, if you do it practically. You can pause the video and try it out. So that is the beauty of physics. Example number 2. Pause the video and try out this. Number 2, we're going to do the same thing. So you can either begin with the 6 newtons is going to the left, and where the 6 stops is where the 8 begins from, and the 8 is going upwards. 8 newtons. So where the 6 begins from, you draw a line to where the 8 ends, and that will give us the direction of the resultant of forces. Or you can simply begin with the 8 newtons, and where it stops, the 6 begins from there. The 6 is going to the left, so draw it like this, 6 newtons. And from the beginning of 8 to the end of 6, that is where you have the resultant force acting. So from our Pythagoras theorem, A, B, C, we shall say that A squared plus B squared is equal to C squared. Our A is 6 squared, B is 8 squared, that in other words, and then we have our C squared. So 6 squared you get 36, 8 squared you get 64, this is equal to C squared. So 36 plus 64 you get 100, this is equal to C squared. Therefore, C squared is equal to 100. From this step, what do we do? You take a root, and this is the same as C being equal to 10 newtons. In case you got this right, that is wonderful. Okay, example number 3. Calculate for the resultant force. You can pause the video and try to this. Maybe a hint. What you do is that you first of all look at one plane. Look at only the horizontal forces, get the resultant. Look at only the vertical forces, get the resultant, and then combine them on a diagram. Okay, so you can either do it like this, that when you look at these two, they're all pointing in the same direction. So we can have 4 plus 8 to give us 12. And this is going to the right. Then 2 is moving up. 3 is also moving up. So you simply add them. 2 plus 3, you get 5 newtons. So you come and draw. You may even not draw another diagram, but let me just do it here. Upwards 5 newtons, rightwards you have 12. So this one will give us our diagram that we have 12 newtons. You can even begin with the 5. So the 12, where the 12 stops is where the 5 begins from. So we have this one as 5 newtons. So from the beginning of 12 to the end of 5, that is where we have our resultant. And this is a right angle triangle. So if this is A, B, C, then we shall have that A squared plus B squared is equal to C squared. In other words, 12 squared plus 5 squared is equal to C squared. 12 squared is 144. 5 squared is 25. This is equal to C squared. 144 plus 26. This is the same as 25. This is the same as 169. This is equal to C squared. So C squared is equal to 169. Take the square root of C squared. Square root of 169. Use a calculator. Your C will be equal to 13 newtons. In other words, in case you don't want to draw this diagram here, you simply come and say that since I have the 12 going to the right, I have my 12, and then I have the 5 going upwards, I have my 5, and then you draw up the diagram like that. It is also very okay. So that is number 3. So let's try out the last number here, number 4, then you try out an exercise. So number 4 says that calculate the resultant of forces. So in this case, what do we do again? So we shall simply do the same thing. So we can begin by looking at the vertical alone. The resultant vertical, you can simply say that 100, anything going up, we can give it positive, anything going down, we give it a negative. So 100 minus 20 plus 5 minus 5. So this is 100, then this one's going down, subtract. This one's going up, you add. This one's going down, you subtract. What answer do we get? 80 newtons. And this is going upwards. Then horizontally, we have 36 is going to the right, then you add 24, here we get 60 newtons. So our diagram, and this is going to the right. So our diagram will look at like this. You can begin with 60. So where the 60 stops, the 80 begins from there going upwards. And where the 60 begins from and where the 80 ends, we draw our arrows. So that will give us our first diagram. Or you can begin with the 80 and you draw it upwards. This is 80. Then where the 80 stops, the 60 begins from there. It is going to the right. This is 60. And from where 80 begins from, you draw a line up to where the 60 ends. So that will give us the resultant. So this is a right angled triangle. So we shall say that a squared plus b squared is equal to c squared. When you substitute here, we shall have 60 squared plus 80 squared is equal to c squared. So calculate for the c. You find that your c is equal to 100 newtons. And that is how we calculate for the resultant of forces. Of course, when you go to A level, I shall be having these forces acting at different angles, at 30, at 40, at 80, at 240 degrees, and we use different methods. But for now, at this level, shall be basically looking at horizontal forces, vertical forces, and then forces where we have a 90 degrees. So with this, I come to the end of our lesson, and next is a quiz for you. But below this video, you can click on the word here and get more practice questions before you attempt the quiz in the next part. Thanks for attending. See you.